Solving equations of the form a times bx minus h squared equals k. So looking at this sort of generic equation, a times bx minus h squared equals k, I want you to start thinking ahead about which numbers you'll move away from the x first, and which ones will have to be the last to go. And we did this previously, but the new addition is this b, which is multiplied by the x. So what are we going to move away first? The first thing that's most loosely attached to the x is the a. The next thing that's most loosely attached is the thing that's locking bx minus h in those brackets, which is that squared. So that's the second layer of the onion that we'll have to peel away to get to x. And then we'll be left with bx minus h. And because the b is multiplied directly to the x, that minus h is not as strongly as attached. We could add that or subtract that to either side of the equation, whether it was a plus h or minus h. So if that's a minus h, that'll be the third thing we'll move away from the x. And then that last step that we'll have to do is to divide the b off the x. So that's the that's the general approach we're going to take. And now we'll see what this looks like in an example. So in this first example, we don't have an a value in front of the bracket. Doesn't matter. We just look at it and we say, what's that outer layer on this left-hand side that we need to deal with? And it's the squared. So we apply that square root property, and we say that 2x minus 3 is plus or minus the square root of the right-hand side. And I'll go ahead and simplify the square root of 12 to 2 root 3 just now here in this middle step. I could have done it later, but I'll just do it here now in the middle step. Then what's the thing that we have to move next away from the x? The thing that's most loosely attached is the 3, because we can just add 3 to each side and it doesn't affect the x at all. The 2 is more strongly attached because it's directly right on the x itself. So we'll add 3 to each side, left with 2x equals 3 plus or minus 2 root 3. And finally, we'll divide each side by 2. So we get that x is equal to 3 plus or minus 2 root 3, all of which is divided by 2. And it's really important that everything is divided by 2 on the right-hand side, because when you divide each side of the equation by 2, you have to divide everything on each side. So that would be one way to write the final answer. Another way to write the final answer, if we wanted, and I wouldn't recommend this, I like this final answer, but another valid solution would be if you were to divide, or if you were to split apart that fraction as 3 over 2 plus or minus 2 over 3, 2 times root 3 over 2. And just like how we combined fractions with a common denominator, you could also split them apart, split those numerators apart, and that would let us simplify 2 root 3 over 2. So we could write this as 3 over 2 plus or minus root 3. That would also be a totally valid solution to this equation, but I like the way, this is the way you're more commonly going to see it. So here we have the second example, and we have a lot going on. But again, we just start with what do we move away from the left-hand side of the equation first? And we'll have to start by moving away the 30, because it's very loosely attached to this whole item here, this whole term, which has multiplication and then a bracket squared. The negative 30 is very easy to move to the other side of the equation with subtraction, so we'll do that. And then we'll divide each side of the equation by 2, leaving us with 5x plus 1 squared equals negative 15. And now we'll use that square root principle. If we have something squared equals k, then we have 5x plus 1 equals the positive or negative square root of the right-hand side. Looking at this now, we see that we have 5x plus 1 is equal to plus or minus the square root of negative 15. And now we realize all of a sudden that there is no solution to this equation. And that is our final answer to this problem, that there is no valid solution to this equation. Well, I should say there's no real solution to this equation. In future math courses, you'll actually see that there are there are ways to solve this equation, or at least to there are ways to deal with this equation. But there's no real number solutions because you can't take the square root of negative 15. If we look back at this step here too, when you see negative 15, something squared equals negative 15, your alarm bell should be ringing because anything squared produces a positive number. So when you have something squared equals negative 15, you should be thinking right away, ooh, this doesn't look good. But I like to get to this step where you have the square root of negative 15 just because it very solidly confirms the issue with this equation. And one last example where you really have as much going on as you can in this type of problem. And we're just going to follow the same step, which is to move the thing that's easiest to move to the right-hand side of the equation. That would be the negative 3/2. By adding 3/2 to each side, we move it over to the right-hand side. So we have 2 3z plus 6 squared equals 1 plus 3 over 2. So 1 plus 3 over 2, 1 we'd write as 2 over 2, and then we add 3 over 2. So 2 over 2 plus 3 over 2 would be 5 over 2. So that's what's on the right-hand side. Now we're going to divide each side of this. Equation by 2, but I'm instead going to write it as multiplying by a half because that's going to make combining the right-hand side a lot easier. So I multiply each side by a half, and obviously if you have a half times 2, the 2's cancel. But on the right-hand side, I have 5 over 2 times 1 over 2, which is 5 over 4. And on the left-hand side, I still have 3z plus 6 squared. Now I'm going to apply that square root principle. So that means that 3z plus 6 is equal to the positive or negative square root of 5 over 4. And 4 in the denominator is a perfect square. So that's the same as root 5 over 2 by taking the square root of the top and bottom independently. And now I'm ready to start moving some terms over to the right-hand side here. So I'm going to subtract that 6 from each side. 3z equals. And again, I usually write that in front of the radical term. It's just what we usually do by convention. And now we're going to divide each side by 3. So we're dividing the whole side by 3. So I have z equals negative 6 plus or minus root 5 over 2 over 3. This is not a good way to write a solution though. So I'm going to go ahead and simplify this a little bit more over here. And the way I'm going to do that is by splitting apart this fraction. So I have negative 6 over 3 and then plus or minus root 5 over 2 over 3. Because you never want a complex fraction in a solution. So what's nice here is that on the first term, negative 6 over 3 simplifies to negative 2. And to simplify this complex fraction, we'll just rewrite it as a division problem. Or sorry, I'll say we're going to use we're going to rewrite this division problem as multiplication by a fraction. So root 5 over 2 divided by the 3 is the same as root 5 over 2 multiplied by 1/3. And that lets us combine root 5, combine those denominators, root 5 times 1, and then 2 times 3 is root 6. So z equals -2 plus or minus root 5 over 6 is the cleanest way you can write this solution.